After preparing in the previous lesson by learning about different kinds of special triangles, we are now ready to learn some more techniques for solving geometrical puzzles involving angles. Let's start by looking at a little more symmetry. Here I have an ordinary triangle, nothing special. We call this a scalene triangle. Let's say I want to know what the sum of the red, green and blue angles is. In order to see what this is going to be, let's pick up the red angle, rotate it under 180 degrees and put it next to the green angle. Since I have rotated this line segment by 180 degrees, these two line segments will now be parallel. And these angles, of course, are just the same angle, but rotated. Let's do the same for the blue angle. Again, this line is just this one, rotated over 180 degrees. So these lines are again parallel. And that means that these arms here actually form a straight line. You can see this in the image as well. Maybe you see where this is going. The red, green and blue angle together form a straight angle. And that means that the sum of the angles in a triangle, which is also the red, green and blue angle, is the same as in this straight angle. So the sum of the angles in this triangle is 180 degrees. And this trick actually works no matter the precise shape of the triangle. It works for all triangles. So we can conclude that the sum of the angles of a triangle is always 180 degrees. And this means that if we know two of the angles of any triangle, we can always calculate the third one. For example, if I have this triangle where I know that this angle is 80 degrees and this is 60 degrees, then what can this angle be? Well, the three together have to be 180 degrees. This is already 140, so this angle has to be 40 degrees. If these are 35 and 25 degrees, then this can only be 180 minus 35 minus 25 is 120 degrees. And if these are 35 and 110 degrees, then this has to be 180 minus 35 minus 110 is 35 degrees. So it turns out that this is an isosceles triangle, where these angles are the same and therefore also these sides. When we use this rule to perform calculations, we call it the angle sum rule. So in this triangle, if we are asked to calculate angle C, what we write down is this. We say angle C is will be equal to 180 degrees minus 80 degrees minus 60 degrees. And I know this is the case because of the angle sum rule, because of the angle sum of a triangle. And then, of course, in the next line, I'll simplify this calculation. I'll resolve it to 40 degrees. So that's the basics. Now let's see how knowing the properties of special triangles actually gives us some extra handles on calculating angles. The simplest case is the equilateral triangle. We know that all the angles of an equilateral triangle are the same. And now we also know that they add up to 180 degrees. So 3 times this angle is 180 degrees. Well, that means that each individual angle has to be 60 degrees. So in an equilateral triangle, all angles are always equal to 60 degrees. Also relatively straightforward is the right angle triangle. The right angle is simply a second angle that we know. For example, if one angle in a right angle triangle is 54 degrees, then we know that there has to be another angle that is 180 minus 90, right angle, minus 54 is 90, minus 54 is 36 degrees. And finally, we have the isosceles triangle. And if we know what the equal sides of a triangle are, or what the base is, then it turns out we need only one angle to calculate all the angles in the triangle. Let's see how this works. The first case would be this, where the angle we are given is one of the base angles. And well, we know that the base angles are equal. So in this case, the other blue angle will also be 69 degrees. And now we know two angles, so the remaining angle has to be 180 minus 69 minus 69 is 180 minus 138 is 42 degrees. That's the first case. The second case is where we know the vertex angle. So let's say the vertex angle of our isosceles triangle is 30 degrees. Then the other two angles together have to be 150 degrees because of the angle sum rule. So blue plus blue is 150 degrees. But the base angles are equal. So what we're actually saying is 2 times this angle is 150 degrees. Well, that means that this angle is 75 degrees and this one is as well. So isosceles triangles are easy if we have the images, but they can be tricky without them. And that's why we always draw a sketch of the triangle before we start calculating. And we'll do one final example here together. In triangle KLM, side KM is the same as KL, and the angle at vertex M is 40 degrees. Can we calculate the angle at K? So I see that 2 of the sides are the same, so this is an isosceles triangle. And that means I can simply draw a sketch of an isosceles triangle. The precise angles don't matter. We're not going to measure anything. We're just going to use this sketch to make clear to ourselves what the vertex angle is and what the base angles are. The equal sides are KM and KL, so they meet in K. That means K is the vertex angle and the other vertices are L and M at the base. Angle M, it says, is 40 degrees, so we also write that in our sketch. So this is one of the base angles. And again, the angle in my sketch is definitely wrong. It's definitely more than 40 degrees, but that doesn't matter. Now we can start calculating. The base angles are equal, so L will also be 40 degrees. We can write that down. And now the angle sum rule tells us that K has to be 180 minus 40 is 100 degrees. Now for your homework, you'll be practicing with calculating angles in ordinary and in special triangles. And coming up in this video is a solution to exercise 27. I would again advise you not to watch it until after you've tried to solve the exercise for yourself. So good luck with that and see you next time. So let's take a look at the problem in exercise 27. We see a fire engine and it says when the ladder is in a certain position, the angle, so this position, then the angle B, the angle that B makes with the vertical direction is equal to 70 degrees. This is 70 degrees and this is a vertical line. And now the driver moves the ladder up by another 15 degrees. And now we want to know what this angle is going to be. This image is very colorful, but also thereby a bit confusing. So let's first make a sketch where we see just the information that we need. Basically what we have here are 2 right-angled triangles. This is horizontal, this is vertical, so the angle at A is right. And we can also imagine this vertical line, we can imagine extending it, and then we'll have another right triangle. Let's say that this point is E, and then this triangle would be EDC. So we make a sketch with just those triangles, and we know that because this is horizontal and this is vertical, these angles will be right angles. So we have 2 right-angled triangles. Some of the other angles in this image we also know. We know that the angle at B is 70 degrees, and we know that the angle here is 15 degrees. Now let's see if that's enough. We have a triangle here, and we know the angle sum rule tells us that this plus this, A plus B, plus the small angle at D here, the lower angle, will be 180 degrees. This is 90, this is 70, so this has to be 20. Now we can look in triangle EDC, because we want to know angle C. And then we know that this is 90, we know that this is 35, so that together is 110, 125. And if we want to go from 125 to 180, then we have 55 degrees left. So angle C here will be 55 degrees.